Hello everyone. In this video, we are going to solve first missing positive problem from Leet code. So the problem description goes like this. Given an unsorted integer array, find the smallest missing positive integer. And they have given us 3 examples to work with. So these are the examples that we are going to use in our solution to test the correctness. So in this video, we are going to discuss multiple solutions. If you want to skip to the most optimized solution, then please look at the description so that you can skip to that part directly. So let's see what are all the solutions that we have here. So I would first do a naive solution with time complexity of O of n square, and the second solution would be with O of n log n, and the third solution is going to be time complexity of O of n with space complexity of O of n, and the fourth solution is going to be time complexity of O of n and with use of constant extra space. So let's get to our first solution. Solution 1. Time complexity O of n square. So what we are going to do here is we are going to have a for loop. So first, input is going to be passed as a list of integers. So we have to find the length of it. Size is equal to length of input. Now we are going to iterate over the integers from 1 to the size of the array. So it's going to be for I in range of size. And then now we want to find out if the I is present in the input list or not. If I not in input, return I. So if we don't find such an value, then what we are going to do is we are going to return the size. And one more thing we need to keep in mind is 0 is not a positive integer, so we should not look at 0. So I'm gonna modify the range from 1 to size. And here what we are doing, I would explain it again. So for I in range of 1 comma size, so we are going to iterate over all the numbers from 1 to the size of the array, and then for every number I'm going to check whether that number is present in the input or not. If it is not present, then I'm going to return I. So this for loop is going to take time complexity of O of n, and there is going to be a nested check. So we are iterating over the input every time to find out whether element is there or not. So there is a nested loop here, so which makes the time complexity O of n square here. So let's run the solution. Yes, the answers are correct as per Leet code's expectation. Now we are done with our first solution. Now let's move on to our second solution. So solution 2, time complexity is going to be n log n. So what we are going to do here is we are going to get the input and we are going to sort the input. Sort. After sorting it, we are going to have a counter, and the counter is going to start from 1 because 0 is not a positive integer. And then I'm going to iterate over the elements in the input for I in input, and then I'm going to check if I not equal to counter, then return counter, else counter equal to counter plus 1. So what we are doing here is we are iterating over all the elements in the input, and we are checking whether that element is equal to the counter, because since the array is sorted, the numbers are sorted. so it would increment by 1. So if the number is not equal to counter, then we are missing that number in the list. So that would be our first missing positive number. If that number is available, then what we do is we increment the counter and then we check the next element. So this way we would be able to find out the missing positive number. What if we exhaust the counter and we still didn't find the value, which means that all the positive numbers were available. So the last positive number which is not in the array is going to be the last element. So that is the reason we are returning the size here. So let's check the solution. There is a problem with our solution. So let's take a look at it. So now there can be negative numbers as well present in it. So what we have to do is we have to make another check whether if all the elements are greater than 0. So if I greater than 0, then we should be doing all these functions. So now let's run the solution. Yes, answer is correct as per the expectation. So we are good with our second solution. So let's move on to our third solution. So third solution is going to have time complexity of O of n and space complexity of O of n. Here what we are going to do is we are going to store the input elements in a dictionary. So input dictionary equal to for I in input dictionary equal to I equal to I. So now we have stored all the input elements in a dictionary, and then now we are going to iterate over numbers from 1 to the size of the array. 1 comma size. So we are going to iterate over all the elements, and then we are going to check if the number is present in the dictionary. If I in input dict, we can check if I not in input dict, then return I. It's almost similar to the first one where we were checking the list, but list is not guaranteed for a O of 1 lookup, but dictionary is guaranteed for a O of 1 lookup unless and otherwise our hash values are good or sufficient enough to solve the clashing. So now we are returning the size and everything looks good. So let's run the solution. And it looks good. 3, 2, 1, which is the expected answer. Next, this is going to be our optimized solution. So solution number 4, we are going to have a time complexity of O of n and space complexity of O of 1. In this solution, we are going to use the same list that was given to us. Previously, we were trying to use an additional data structure to store the values, but in this one, we are going to use the existing structure and mark the indexes as visited or not, so that we would be able to figure out if the index is visited, then the element is already present. If the element is not visited, then that is going to be our missing value. So here, one of the interesting thing is we have negative numbers present here. So that might cause some issues with our indexing. So for that, what we are going to do is we are going to do a semi-sort by replacing the negative and positive numbers, so that we would be having the negative numbers in the left side of the array and positive numbers on the right side of the array. Now to find the mid element, we are going to initialize a variable called as mid equal to 0, and then we are going to iterate over the array for I in range of size size is equal to length of input, and if input of I is less than equal to 0, then we are going to swap the elements input of I, comma, input of med is equal to input of med, input of I, and then we are going to increment the med variable. Now we have split the array into two. Left side is negative numbers and right side is positive numbers. We are not interested in the negative numbers since indexes doesn't have a negative number, so we won't be able to update whether the particular index is visited or not. So we would skip those. So now I'm going to have the input array as input to input mid, which means that I'm taking only the positive elements and then I'm overwriting the input array. And then I'm going to modify the size as well. Size is equal to size minus mid. Now we are going to iterate over the array. If for I range of size, if here I'm going to use absolute value in case if there are any negative numbers. So absolute of input of I minus 1 is less than size, and input of absolute value of input I minus 1 is greater than 0, then we are going to reverse the value input absolute of input of I minus 1 is equal to minus minus 1. So now we have reversed the value that is present inside. The braces doesn't match. Okay, now it is good. Now I'm going to iterate over the same array for I in range of size if input of I is greater than 0, return I plus 1, because we subtracted 1 in our previous for loop, so we need to increment plus 1 here because of the array starting from index 0. And if we don't find any value greater than 0, then we should return the size. So let's run the solution here. 2, 2, 1. The first one should have been a 3. So what we are missing here is size is equal to size minus mid. So we removed 0 as well here. So we should have added 1 here so that we would encounter the index value 0 here. 3, 2, 1. And this is the correct answer. So we are good with this solution. And in this solution, we just iterated over the elements twice, but not in nested fashion. So the runtime complexity is O of 2n, which is going to be O of n. And we did not use any new data type structures, so there is no additional space complexity involved here. And this is the best optimized solution, which Leet code was also expecting. as they were asking us to write an algorithm with O of n time complexity and with constant extra space. Thank you for watching this video. If you would like to see more Leet code solutions, then please show your support by subscribing to this channel. Thank you. Bye bye.